One of the physics students from class 12 has asked this question with respect to the concept of Einstein's photoelectric equation. Let us discuss this problem. He explained the following observations using Einstein's photoelectric equation. There are three subdivisions in the questions. A. Photoelectric emission does not occur from a surface when the frequency of the incident on it is less than a certain minimum value. It is the frequency and not the intensity of the incident light which affects the maximum kinetic energy of the photoelectrons. Third, the cutoff potential, that is voltage versus frequency of the incident light graph, is a straight line with a slope of h by e. So we need to explain all these three questions. Let us proceed with the Einstein's photoelectric equation. Before that, let us study the phenomenon of photoelectric equation. What is this photoelectric effect? The phenomenon of emission of electrons on irradiation on a metal. On irradiation means when the light is incident on the metal, electrons are ejected from the surface, and this phenomenon is called photoelectric effect. Einstein was able to establish a photoelectric equation. He suggested the maximum kinetic energy with which the electrons are ejected from the surface on irradiation is equal to h nu minus phi. Here, K max is the maximum kinetic energy of the photoelectrons. The electrons which are emitted from the surface on irradiation are called photoelectrons, and they possess certain kinetic energy. So he talks about the maximum kinetic energy. Now let us discuss the right hand side of the equation. H nu represents photon, where H is called the Planck's constant. Nu frequency of incident light. Phi is work function of the metal. It is also expressed as H nu naught, where nu naught is the threshold frequency. That is the minimum level of or minimum frequency so that the electrons are capable of coming out of the surface. Now, let us proceed with the first question. No photoelectric emission below a minimum frequency. So here we have got already this equation K max is equal to h nu minus phi. As I already mentioned, phi represents the work function. Here, for electrons to be emitted, the kinetic energy must be definitely greater than zero. So the photon, that is h nu, must be greater than phi. It means nu should be greater than nu naught, because the phi can also be expressed as h nu naught. So h nu is greater than h nu naught. H being constant, nu is greater than nu naught. So here the nu naught is equal to phi divided by h, and that is called the threshold frequency. So if the frequency is less than nu naught, the photo energy, that is h nu, the photon energy h nu, is not enough to overcome the work function. And that is why there is no photoelectric emission, regardless of the intensity. So this is the answer for the first question. Second question. Maximum kinetic energy depends on the frequency but not intensity. So here As I already explained about the K max that is equal to h nu minus work function, with the increase of K max, that is maximum kinetic energy, linearly with the frequency, and this intensity affect only the number of photons and not the energy per photon. So the energy of each photon is fixed by frequency. Therefore, E photon, that is energy of each photon, is h nu. Thus, increasing intensity increases the number of electrons emitted, but not their kinetic energy. Therefore, frequency controls maximum kinetic energy and not at all intensity. Now, let us move to the third part of this question. We need to establish the cutoff voltage versus frequency gives a straight line of slope h by E. Now let us consider the stopping potential, that is V naught. EV naught is satisfied when K max is there with the equation h nu minus phi. Now we can equate this V naught with the h nu minus phi whole divided by E. Now let us split the equation. So h by E into V minus phi by E. So this equation resembles the straight line equation, that is y is equal to mx plus c. So let us compare these two equations. When V naught is uh, plotted in y-axis and nu is plotted in x-axis, naturally h by E becomes the slope, that is m. So slope m is equal to h by E, and the intercept, that is C, is minus phi by E here. So the graph of V naught versus V is a straight line with the slope h by E. So this is one of the very nice questions, so frequently asked questions. So if there is any further doubt or if you've got any problem with some difficulty level, you can contact us. Thank you.